The next type of transformation that we're going to look at is reflections. Reflection is another type of our rigid motion. When we have a reflection, we remember that as a flip over the line called the line of reflection. Each point in the image is the same distance from the line of reflection. So that's how we're going to figure out what our new ordered pairs are. A reflection is also an example of rigid motion, like I said at the beginning. Our common lines for lines of reflection can be the x-axis or the y-axis. We can also do any horizontal or vertical line in the form of x equals some number or y equals some number. And the last kind of reflection that we can deal with is diagonal lines like y equals x or y equals negative x. So we're going to look at those three different cases. The first is looking at reflecting over our x and our y axis. This is something that you did in pre-algebra. With this, they're going to tell us our ordered pairs, just like before, our vertices for our shape. And then they're going to tell us how we are reflecting. In this case, for number 1, they told us the x-axis. The easiest way to figure out what our new points are is to graph the pre-image. And then, once we have the pre-image, figure out how far the point is from the x-axis, and then just do the same thing on the other side. So the top figure is our pre-image of our triangle. And we can see that from the x-axis, point C is 1 unit away. So to do the image of C, to do C prime, we're going to go to the x-axis, and we're just going to do 1 unit away in the opposite direction. Same thing with point A. From A to the x-axis, we went 2 units. So we're going to go on our x-axis, and we're going to go 2 units the opposite direction to get A prime. B is the same exact way, so we're going to count how many units to the x-axis and do the same thing the opposite direction to get B prime. Once we have the image graphed, then we can figure out what those ordered pairs are. So it might be a little hard for you to see, but these are our new image points, and that's with our x-axis. Number 2, we're still going to do the same thing, but in this case, they want us to do the image over the y-axis. So we're going to start by graphing our pre-image. So we have that rectangle, and then we're going to count how many units to get it on the other side. So point P is 1 unit away from the y-axis. To get P prime, we're doing it 1 unit in the opposite direction. To get Q, we did 2 units. To get Q prime, we're doing it 2 units in the opposite direction. That same process is going to keep happening for R and S. And then once we have our graph, we can figure out what the new ordered pairs are for our image. 3 and 4 are the same thing, so I'm just going to show you those answers. 3, we're going over the y-axis, so we're still just counting. The one thing to pay attention about with number 3 is point H. Since point H is on our y-axis, when we reflect it, H prime is still going to be there as well. I didn't have to do a distance. 4, we're going over our x-axis and counting again, so I'm going to show you those points. So going over the x and the y-axis is the most basic form of our reflection. The next point that we're going to look at is reflecting over any other vertical or horizontal line. So remember, when we have x equals a number, that is our vertical line, and when we have y equals a number, that is our horizontal line. With number 5, they told us that x equals 4, So that is the line that we're going to reflect over. We're still doing the same exact process. So once I graph my line, it is important to graph x equals 4 so you can see where we're reflecting over. I'm going to graph my pre-image and then just count the distance from x equals 4 to graph the image and then fill in my ordered pairs. So when I do that, we are just doing the same exact process. Number 6, we're doing that process again, but our line is x equals -1. So we're first graphing the vertical line x equals -1. If it helps, you can always put it in another color. And then we're just counting the distance so we can replicate it on the other side. Once we graph our image, then we can find those ordered pairs. 7 and 8 are the same process, but this time we are looking at our horizontal lines, our y equals lines. So with number 7, the line is y equals 2, and with number 8, the line is y equals -5. Same thing, we are graphing our pre-image, counting the distance from our line, graphing the image, and then getting those ordered pairs. So once you get the hang of that process, all of these go pretty quickly. This next part is a little more complicated just because you have to make sure you are counting properly. But again, it's not too bad once you get the hang of it. When we do this, we are reflecting over the lines y equals x and y equals -x. Just in case you forgot from algebra, when we graph the line y equals x, that is a line that is going through the origin with a slope of 1. If we do y equals -x, that is still going through the origin, but that's a slope of -1. The first step will be to graph that new line, so the y equals x or y equals -x, so we can figure out how we're going to reflect. In this case, we have our y equals x line, and it's dashed just so you can see it a little more clearly. Then we're going to graph our pre-image just like before. To get our image, it's a little more complicated, but what I suggest is that you pick one point to figure out the distance between our line of reflection, and then base everything off of that. So if I were to look, if I pick point Z, Z is 1 unit away from our line of reflection. So Z prime is going to be 1 unit away from our line of reflection. To get Y prime and X prime, what I would do is I would figure out the relationship that it had with Z and the point on the side. So if I look at Z to Y, I go up 1, 2, 3 and over 1, 2. To get Y prime, I'm still going to go 1, 2, 3 and then 1, 2. It's just in a little bit different direction because I reflected it over my Y equals X line. Same thing with Z. I would count from Z to X. So you would go down 1, 2, 3, and then over 1, 2, 3, 4. So from Z, we would still go 3 and then 4. Once it's graphed, we can figure out our new ordered pairs. If you look at the ordered pairs between the pre-image and the image, when we're reflecting over the line y equals x, we're just switching our numbers. So the pre-image for x was -5, -2. The image for x prime is -2, -5. Same thing happened with our y's. Y was -3, 4. Y prime is 4, -3. So if it's a little hard for you to see the counting with the line of reflection, You can try getting your new points that way. For number 10, we can try it that way. So we have our rectangle with our vertices, and we're reflecting over y equals x. If we reflect over y equals x, that means we're just going to switch our x and our y. If I have g as 2, -1, g prime would be -1, 2. If I have h as 7, -1, h prime is -1, 7. The same thing is going to happen for I prime and j prime. So I personally think that way is a little bit easier when we're reflecting over the y equals x line. When we reflect over the y equals -x line, there's also a little bit of a shortcut we can take with our ordered pairs, but there's two things that we have to remember for this. So just like before, our orders is going to switch. So if I look at A, -1 and 3 would switch positions, but since I'm reflecting over the negative x line, then I'm also going to do the opposite sign for each thing. So if we did A prime as an example, I would switch -1 and 3 to become 3, -1, but then I'm going to do the opposite sign. So it would be -3, +1. For B, I would switch 0 and 6 to become 6 and then 0. And then I'm going to do the opposite sign. So it's going to be -6, 0. Remember, 0 we can't really change the sign of. 0 doesn't have a positive or a negative assigned to it. We'll do the same exact thing for C and D. We're going to switch those positions and do the opposite signs. 12, we can also do our shortcut. So if I do my shortcut, I am switching -1 and -6 and doing the opposite sign to be 6, 1. T and U will work the same way. So I think those tricks are a little bit easier for reflecting with our lines of y equals x and y equals -x. Just like with translations, we can also identify what the reflection is that's happening. So to figure out what our line of reflection is, sometimes it's helpful to figure out what the midpoint of the corresponding points would be. So remember, our midpoint formula is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So what they mean by that is you could take like j and j prime and find the midpoint, or sometimes you can just easily look and see. So for example, number 13, we can easily see that our line of reflection for that is going to be our x-axis. Some of the others, though, it might be a little harder to tell. So that's where our midpoint would come in handy. Number 14, we see that the sides are diagonal, and so since it's sort of diagonal, we're using our y equals -x line. For number 15, it looks like there is a line in between r and r prime, and that line is going to be x equals -3. Number 16 is a little hard to tell, which is where the midpoint formula could come in handy, but we're actually using the x-axis. Number 17, it looks like we're going to have a horizontal line. So if I find the midpoint between these two, I'm going to find that my line is y equals 1. And then our very last one, again, it's a diagonal line, so we're using y equals x. So those are the things that we can do with reflections in transformations.